Good morning, 7th grade. So I hope you are doing well. This week we are going to review proportional relationships, and this could be with graphs, this could be with word problems. So we're going to do a little bit of both before you start your problem set, which is on Study Island this week. It is 10 questions and you have multiple attempts. So let's get started. First things first, in order to determine if something is proportional or not, we need to look at that rate of change. And the rate of change is going to compare two quantities. Those two quantities could be anything. Miles per gallon, dollars per pound, that keyword being per there. We're talking about comparing two quantities. So a proportional relationship is when that rate of change is constant, or which means it's the same. So for example, if you go outside for 60 minutes a day, that your rate of change would be 60 minutes per day. But let's say you went outside for 45 one day, 36 one day. Those are different because it's changing per day. So when we find our rate of change, we call this the constant of proportionality. Remember, AKA, that's just our fancy math language for rate of change. And to do that, we are just going to do our y divided by x. So whenever you look at a table, whenever you look at a graph, things like that, you're always going to be doing y divided by x. So if you take a look below, you can see there's two graphs and two tables. When we look at the graph on the left, we can see that it does start down here at 0, 0. So this one does start at the origin. That's where it starts. And then I can see, I'm looking at my table and I can see some points here. I see I've got 2, 6, which means I go over to 2 and up to 6. And then I see I've got 3, 9. If I go over to 3 and up to 9, so those points are on there. So if I go ahead and do my y divided by x, 6 divided by 2 gives me 3. 9 divided by 3 gives me 3. And 15 divided by 5 gives me 3. So those unit rates are all the same. So I take a look and I've got 3, 3, and 3. So this one would indeed be our proportional relationship. It starts at the origin and the unit rates are all the same. Conversely, if I look at the graph on the other side, I can see that it starts all the way up here. It starts at 0, 3. That is not the origin, which means it doesn't not start at the origin, which means it's not proportional. And again, if I check my y divided by x, if I look at my 2, 4, which would be right here, and I do 4 divided by 2, that gives me 2. And then I look at my next point here of 4, 5, right here. 5 divided by 4 gives me 1.25. Those unit rates are not the same. So this graph over here would be not proportional. The graph on the left would be proportional. Graph on the right would be non-proportional. Alrighty, so what I'd like you to do is I want you to pause it and I want to see what you can do on your own, and then I'm going to talk through my solution. So again, I'm going to ask you to pause it in 3, 2, 1, and then once you hit play to resume, my solution will pop up on the screen. Alrighty, so if you take a look, I know it's a lot of work on the screen. Let's take a look step by step. So the first question asked, is the relationship between distance and time a proportional relationship? And remember, you can always label your table as X and Y, remembering that money will always go on top, because remember, we are doing Y divided by X to check our table, to check our graph, either way. So if I take a look, I did 19 divided by 2 to get 9.5. 28.5 divided by 3 to get 9.5, and 76 divided by 8, and I got 9.5. So yes, it's proportional because all of the unit rates are the same. Then it asks, what would the equation be? Well, I asked you over here on the side to remember that if I go ahead and highlight this here, remember that y equals kx. That was on that first screen. Remember, this k right here is our constant of proportionality, aka our unit rate. So if it ever asks for an equation, just find the unit rate, and then it's y equals that number x. And then the third question said, how can you use your equation to find the cost of 6 pounds of cashews? Well, since the pounds was the x, I'm going to go ahead and multiply my unit rate by 6, plugging that 6 in for the x right there. And then remember, units are super duper important, so it would be $57. Alrighty, so in the next slide, we are going to tackle solving a word problem with proportion. So this will have no graphs, no tables. You'll be setting a proportion yourself. Alrighty, so we can see here for our last example, we have a little word problem on the left, a setup for a proportion in the middle, and then the work on the side. So if I take a look at this word problem here, it says that Mary ran 2 miles in about 23 minutes. So again, I see I've got two different quantities. I've got miles and I've got minutes. Then I see if she continued at the same pace, how long will it take for her to run 10 miles? Again, I see I've got miles and miles, minutes, and then it's asking me how long. So I'm trying to figure out how long that is. What I'm going to do is I'm going to set up a proportion. This way I can just cross multiply and solve. Remember, there are always multiple ways to solve it. If you have a way in your brain that works, absolutely, go for it. For me, I see that I've got miles and minutes. So I'm going to put miles on the top. And I'm going to put minutes on the bottom. And I'm going to take a look and I see she ran 2 miles in about 23 minutes. That was my first piece of information. And then it says, how long will it take her? Well, we don't know how long that is, so that's going to be our question mark. And it says to take 10 miles. Well, miles will go on the top. Miles on the top, minutes on the bottom. What I can do is I can say, okay, well, since I don't know how long the minutes are going to be, pick a variable. Any letter of the alphabet. I'm just going to pick X, tried and true. And then I see I have a proportion. I have 2 over 23 equals 10 over X. And then I can just go right on through and I can cross multiply. So I'm going to do my 2 times X. And then I'm going to cross multiply the other way. And I have my 23 times 10. I see here 2 times X is going to give me 2X. 23 times 10 is going to give me 230. And look at that. I have a one-step equation. Bingo, bango, bongo. Divide both sides by 2. X is going to leave me with 115. Now, when I take a look here, 115 what? What was I looking to find? Well, I was looking to find the time, which in this case would be in minutes. Again, because that X was on the bottom. So my answer would just be 115 minutes. And you can do this with any 2 quantities. If you had miles per gallon, if you had dollars per ounce, anything like that. Set up a proportion using those 2 different units. Put one on the top, one on the bottom. A lot of you in class would do miles over miles, minutes over minutes. Just make sure you're keeping those pairs together. Alrighty, 7th grade. I hope this was a short and sweet little review of proportional relationships. Do not forget, you can go back and review, rewind, pause, and if you have any questions, please do not hesitate to send me an email. It's a great day to have a great day.